Hi! Today we are going to be learning about systems of inequalities. So far we've talked about systems of equations where we graphed two lines on the same graph and then figured out where they intersected for our solution. We've talked about and learned how to graph one inequality on a graph, and we figured out how to shade them and to decide what kind of line we were going to use. Now we're going to do systems of inequalities. So just like on number one, you'll see we have two inequalities shaded at the same time, and we're going to learn about what their solution is. So the solution is where you will see a double shaded region. So when they shaded this question or these inequalities on this question, they shaded below both lines, and there's a place where they're both being shaded, which is right here. So it usually looks just darker when the worksheet already has it shaded for you. So the double shaded region and any solid line that's bordering the double shaded region will be part of our solution. So what we're going to do first is we're just going to walk through these first few ordered pairs and decide whether they are solutions to the system or not. So the first ordered pair, 0, 0, I'm going to put that point on my graph, and I see that it's not in the double shaded region, so that means that it is not a solution. Then I'll look at the point -3, 0, that's over here. That one is part of the solution. So -1, -5 is going to be down here. Again, yes, that is part of the solution. 1, 2. So I'm looking to see, is it in the double shaded region? No. -4, 3. 1, 2, 3. That point goes right there. Again, not part of the solution. And then -4, 0 is over here on the solid line that borders the double shaded region. So that point right there would, yes, be part of our solution. So we're looking for points in the double shaded region, and then if it's on the solid line that borders the double shaded region. Dashed line, still not part of the solution. Okay, next we are asked, is 2, -3 a solution to the system of inequalities? That's written right here. So we did this a little bit in our notes from the previous lesson. We are going to figure out if this is a solution by plugging in the ordered pair. So I have an x value of 2 and a y value of -3. And I'm going to plug that into both
Release group C. Release group C.
inequalities. And I'm going to be looking to see if it makes a true statement. All right, so let's plug that in to this first inequality. 8 is greater than or equal to 2 times 2 minus -3. So where I see a minus and negative, I'm going to go ahead and change that to plus plus. Then as I simplify, I've got 8 is greater than or equal to 4 plus 3 is 7. So then I need to think to myself, is 8 greater than or equal to 7? Yes, it is. It's an ugly check mark. Okay, so that right there fits the solution. However, I need to also make sure that this ordered pair is a solution to the second inequality before I give my final answer. So now we're going to plug it into 2y. So 2 times -3 is less than -4 times 2 minus 2. So we're going to simplify here and see if this one's true. So that would give me -6 is less than negative 4 times 2 is negative 8 minus 2. So negative 6 is less than negative 10 is what we end up with. So think to yourself, is negative 6 less than negative 10? No, it's not. So since this ordered pair does not make a true statement for this second inequality, that means no, it is not a solution. So it has to make true statements for both inequalities in order to be a solution. And this one is not. Okay, now we're going to get into some graphing examples. For number 3, well, we always want to make sure it's solved for y, which number 3 already is. So we're going to graph y is greater than or equal to 2x. I always like to think about where I will shade and the kind of line before I start. So if I see y is greater than or equal to, I need to remember that that means I'm going to shade above the line. And since it's got that equal to, that line that's part of it, that's going to be a solid line when I graph it. All right, and then I want to think about the line y equals 2x to graph. So that would be a y-intercept of 0 and a slope of 2. So I'm going to count up 2 over 1 and connect that with a solid line. And then I want to shade above that line. You can like switch colors if you want to. You can shade that with a highlighter if you want to, but just something to show that you've shaded above the line for that one. And then for my second equation, we have x is greater than or equal to negative 1. So remember, that's kind of a special line. An x equals a number line is going to be vertical. So I'm going to switch colors to show my second inequality here. And that would be a vertical line. The line is going through the x value negative 1 right here. It's going to be a solid line. So I'm going to go ahead and sketch that line there. And for a vertical line, this is a greater than or equal to symbol. That would be like still shading above, but if you think about all the x values that are greater than negative 1, that would be to the right of this line over here. So, to fully show our solution, we kind of want to shade in this double shaded region a little bit darker so that we can really tell where it's at. That's where the shaded parts overlap, so that is where your solution will be. Then the directions also tell us to name one point that lies in the solution. So our answers will vary probably with this part, but I'm just going to pick the point 0, 4 as an example. But it could be any point that's in that double shaded region. Number 4, before we can graph these two, we need to solve for y. So first, I'm going to use this space down here. 2y plus x is less than x. 2y plus x is less than x. I mean 6, whatever. I want to move the x term over first. So I'm going to subtract x from both sides. And that leaves me with 2y is less than negative x plus 6. Then our last step to get y by itself would be to divide everything by 2. So y is less than negative 1/2 x plus 3. So let's go ahead and graph that inequality before we move on to the next one. So this one, since it's just less than, there's no equal to there, this will be a dashed line and it will be shaded below the line. So I start out with a y-intercept of 3, and then to count the slope negative 1/2, I can go down 1 to the right 2, or up 1 to the left 2, and draw my dashed line there, and then shade below. Now we need to solve the other inequality for y. So we've got 3x minus y is greater than 4. Our first step, we're going to take over the x term, so we need to subtract 3x from both sides. And that gives us negative y is greater than negative 3x plus 4. I can't stop with negative y, I have to have positive y. So to get a positive y, I'm going to go through and divide everything by a negative 1. And remember, with inequalities, I'm dividing by a negative 1, so that means I need to switch my sign or flip my inequality symbol. So I like to circle it to remind myself to flip it. So as we go through and simplify, we should end up with y is less than 3x minus 4. Now I should think about what the symbol is telling me for my graph. If I had tried to take a shortcut and use the original symbol to decide my line and where to shade, I would have shaded the wrong direction. So you always want to make sure you wait till the end after you're totally done solving for y to decide that stuff. So this is going to be another dashed line, and this one will also be shaded below. So let's graph it. Negative 4 is the y-intercept. 3 over 1 is the slope. And we're dashing and shading below. This one has a pretty steep slope. So remember, the underneath part is the part you need to shade. And then you should easily be able to tell which section is your double shaded region down here in this bottom corner. So they're both shaded underneath right here. A point that's in that solution, how about 4, negative 3? Amazing, I know. Okay, let's do number 5. So we've got our first equation, or inequality, is already solved for y. Turn up, let's graph it. It's going to have a dashed line again. This one, since it's greater than, will be shaded above. All right, it's got a y-intercept of 0 because there's nothing added or subtracted after the x. So y-intercept of 0 and a slope of 1. Just a nice normal line there. So we've got a dashed line. And we're shading above. Then the second one, we do have to solve for y because it's not solved for us. So remember, our first step is to take over the x term. So we will subtract x from both sides. And that gives us negative y is greater than or equal to negative x plus 3. Now we have negative y and we need a positive y. So we're going to divide everything by a -1 to change all those signs. As soon as I start to divide by a negative, I have to remember, flip the sign. So as we simplify, we get y is less than or equal to positive x, because we had negative divided by a negative. And then we have positive 3 divided by -1, that would be -3. So now we can think about our graph a little bit here. We have less than or equal to as our symbol. So that means this is going to be a solid line. And since it's less than, we're going to shade below. Y-intercept is at -3, and then the slope is 1. So I've got a solid line that goes through there, and I'm shading below. Now, if you think back to the very beginning, I said our solution is the double shaded region. Well, for this question, we shaded this way and then the opposite direction. So is there a double shaded region? No. That means that this system has no solution. The inequalities had parallel slopes, and since the shading went opposite directions, nothing overlapped. So this would be a no solution. The last two examples are kind of us working backwards. So we're given the graphs of the systems, and now we have to write the inequalities that fit those. So I am going to have us do number 6 and start with this line first. So this one that was shaded over here. All right, so to write the inequality, we're going to start with y, and then I need to think about the symbol. So I see a solid line that's been shaded above the symbol. The inequality symbol that goes with that would be greater than or equal to. All right, then I want to look at the y-intercept, which is down here at -4. And then the last piece would be to find our slope. So we want to find 2 pretty points and then count the rise over run. 1, 2, 3. And then the run would be 1. So that would be a slope of 3. Now, a good thing to do after you write that would be to check it and make sure it makes sense. So as I'm looking, I want to just double check everything. I have a y-intercept of -4. I can count that slope again. Okay, good. That's 3. Solid line, which means I should have equal to, and it is shaded above, so it should be greater than or equal to. So you kind of might benefit from walking back through and checking to make sure your inequality actually makes sense with what you see. Now let's do the second inequality. So starting with y, let's think about our symbol here. We have another solid line, and this one is shaded below. So solid below means that would be a less than or equal to. Then we can start with our y-intercept, which is at +2. And then find another point that we can use to count the slope. I'm going to use this one up here. So I'm counting the slope between these two good points. So the rise is 1, and the run is going to the left, so that would be a -2. So that's a slope of 1 over -2, or -1/2 x. And then before I'm totally done, I just want to double check everything. So less than or equal to, so I've got a solid line shaded below, a y-intercept of 2, slope of 1 over -2, or -1/2. So we're all good there. We're going to pause and let y'all try number 7 on your own. So see if you can do this process of working backwards to write your own inequalities from a graph. So go ahead and pause, and then you can check your answer. Okay, so here I did the dashed line first. So you should get the inequality y is greater than -1/2 x plus 1. And then the blue one, the solid line, should be y is less than or equal to -x plus 3. And that's it. Have a great day.